Hello children. In the last two videos, we have explained about the laws of refraction and we have also defined what absolute refractive index is. Now in this video, we are going to define relative refractive index. Now relative refractive index is nothing but your refractive index only, but we are defining this refractive index when you have a pair of medium. When you have a pair of media, whenever you have a refraction happening due to the bending of light while traveling from one medium to another medium, we'll use the term relative refractive index. Now you know the definition of relative refractive index. It's the sine of the angle of incidence to the sine of the angle of refraction, ratio of sine of the angle of incidence to sine of the angle of refraction. Now we are modifying this definition like this. Relative refractive index of the two media is defined as the ratio of refractive index of the second medium to the refractive index of the first medium, or I can say absolute refractive index of the second medium with respect to absolute refractive index of the first medium. So if I am going to write, this is the known equation to you. This is something that you already studied. Sine n21 is equal to sine I by sine r, which you called as Snell's law. Now we are redefining this n21 as the ratio of absolute refractive index of the second medium to the absolute refractive index of the first medium. Now let's write what is the absolute refractive index of the second medium. This is nothing but the velocity of light in vacuum or air divided by the velocity of light in the second medium. We know that the velocity of light in vacuum or air is always represented by the symbol c. Okay. So similarly, if I want to write the refractive index of the first medium, I can write it as the velocity of light in vacuum or air divided by the velocity of light in the first medium. Now if I substitute these two expressions in equation 1, what will I get? I will get n21 is equal to, what is n2? That is c by v2 divided by c by v1. So what happens to this expression? C by v2, you have to multiply like this. Your c and c get cancelled. Now you will get it as n21 is equal to v1 by v2. v1 by v2. I'll copy this expression in the next slide. n21 is equal to v1 by v2. n21 is equal to v1 by v2. n21 is equal to n2 by n1 is equal to v1 by v2. Let me call this as equation A for my convenience. Okay. Now let's write down the expression in a reverse manner, that is n12. What is n12? The refractive index of the first medium with respect to second medium. So how can I write it? It is the ratio of refractive index of the first medium to the refractive index of second medium. Now just like what we did in the previous case, we will write down the expression for n1 and n2. What is n1? n1 is c by v1. n1 is the absolute refractive index of the first medium, which is nothing but the velocity of light in vacuum by the velocity of light in medium 1. Similarly, n2 will be equal to how much? C by v2. Now let's substitute those two values in this expression, equation 2. So what happens to equation 2? n12 is equal to n1 by n2 is equal to c by v1 divided by c by v2. So this becomes c by v1 into v2 by c. v2 by c. So c and c get cancelled. I will get n12 is equal to v2 by v1. v2 by v1. Now let me copy this expression here, the expression A and expression B. What is my expression A? n21 is equal to n2 by n1 is equal to v1 by v2. That was your expression A. Now what is n12? n12 is equal to n1 by n2 is equal to v2 by v1. That is my expression B. So how can I define my relative refractive index of the second medium with respect to first medium? It is the ratio of velocity of light in first medium to the velocity of light in second medium. How can I define relative refractive index of the first medium with respect to second medium? It is the ratio of velocity of light in second medium to the velocity of light in first medium. Okay, you have to remember this expression. Those expressions are very important. We need this expression to solve the problems. We need this expression to explain the concept related with refractive indices. Okay, and you have one more important result which you studied as Snell's law, that is sin I by sin R. Let me call this as some equation C. Now let's find out the relationship between equation A and equation B. Now what is N21 is equal to? N21 is equal to V1 by V2. Now can I write this V1 by V2 as 1 by V2 by V1? So if I write like this V1 comes to the numerator, so automatically this becomes V1 by V2. So I can very well write my N21 as 1 by V2 by V1. Now what is V2 by V1 in the denominator? V2 by V1 is your equation B. V2 by V1 is the equation B. What is that? N12. So what can I write here? This can be written as N12. So I am getting another important result here. N21 is equal to 1 by N12. So if you know the refractive index of the second medium, with respect to first medium, then you can easily find out the refractive index of the first medium to the second medium just by taking the reciprocal of the second medium to first medium. You can find it out. If you know N21, you can find out N12. Similarly, if you know N12, you can find out N21. So you have to remember this result also. Now I want to explain one more important thing here, which is something that you have studied in your previous classes and which is something that you should know to solve the problems related with numerical sections. I will rub this area down so as to write those expressions. I don't have a new page here, so I'll rub it and I'll write down the expressions here. Remember this important expression that I have written here. Now, in your lower level classes, we have studied an equation for sound, or in your 9th standard, you have studied an equation for sound. The velocity of sound is frequency of the sound times wavelength of the sound. Velocity is equal to frequency multiplied by wavelength. Now same kind of equation is valid in the case of light also. So velocity of light can be written as frequency of the light multiplied by wavelength of the light. So whatever equation you have studied for sound, same equation can be used here. Now you will see two kind of representation for velocity of light. One is this one, v equal to nu times lambda. Another equation is c is equal to nu times lambda. Now what is the basic difference between those two equations? Now this equation, now I will call this equation as equation D and equation E. Okay, now equation D is used only when light is traveling in some medium. For example, water, glass, kerosene or some other kind of transparent medium. V equal to frequency into wavelength. Okay, and the E expression, the equation E is always used when your light travels in vacuum. So when light travels in vacuum, the velocity is a constant. I know the C value. The C value is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. So whenever light travels in vacuum or air, you can use expression E, and whenever light travels in a particular medium, you can use the expression V V equal to nu into lambda. Hope you understood this particular expressions. Okay, now we are going to use these expressions whenever we solve the problem. So I study all those results: A, B, C, D and E. All those expressions are very important. Okay, now A, B, C is expressed in my notes. It's given in my notes. D and E equation you will see whenever we solve the numerical problems related with the refractive index, velocity, the angle of incidence and angle of refraction. You will understand this in a better manner, how you are going to use these equations in a better manner whenever we start solving the problems related with this section. Hope you understood the difference between absolute refractive index and relative refractive index. I'll give you one simple idea once again. Absolute refractive index is used whenever you have only one media, only one medium is provided, and whenever two media or a pair of media is provided, you have to use the concept of relative refractive index. Okay, now when you go to higher level classes, they will never specify relative refractive, this is relative refractive index, this is absolute refractive index. They will never specify. They will simply tell it as refractive index only. Okay, so when a pair of medium is provided, you have to understand it is relative refractive index. When only one single medium is provided, you have to understand they have provided the absolute refractive index. That is a simple way by which you can identify which refractive index concept I have to apply. Okay, hope you understood this particular section. If you have any doubt, you can call me or you can message me, or we can discuss in the next online session.